Golden Knowledge Bite 2. Tacit and explicit knowledge capture and transfer. During any experience that involves watching experts in a particular field engage in their task, tacit knowledge is transmitted. This knowledge is also termed know-how. It cannot simply be learned from a manual or a set of procedures. Tacit knowledge cannot easily be codified and requires personal experience for this type of knowledge to be gained. We'll see later how BCU practitioners undertaking secondments directly gained this tacit knowledge and how they turned this knowledge into explicit knowledge that could be shared and transferred to their peers and learners. What tacit knowledge did you pick up?
I was quite surprised at the way that things were done in Abbott Diagnostics because it has been a while since I've worked in industry. I was surprised how precisely and slowly things were done to make absolutely certain that they conform to regulations, but that obviously that the end product was always precise and correct because of the nature of the way that they're made and the uses that they're going to be put to. So that's something that I can bring back. That precision is something that I've been able to bring back into the centre and teach to my students.
In terms of tacit knowledge, I think it has to do with how companies actually capture knowledge and share knowledge within these organisations. And a lot of them, because they've been doing it for quite a few years, have developed these sort of protocols. They can't really explain it, but they do it in a particular way for a particular reason. So I was able to capture some of that and make it explicit via my publications, because the main outputs of these were the reports I published and conference papers and journal papers for others to be able to read and access that information.
The whole purpose of learning about what's going on in the industry today by travelling around the larger, more modern dairies within the UK meant that I was able to look at the application of this technology. We also visited a couple of demonstration firms that were showing automated lines and robots, but very much in a laboratory type facility. And you can't really see and understand how that robot can even begin to pick up any artificial intelligence or even work with a process automated line until you see it working. Because when you see it working, then you come across the operational issues of repair, of packages breaking down, of incorrect size labels, different types of formatted packaging, so making the robot either stall, stop or do something different. And until you see that, you don't learn that. So walking alongside some of the engineers in the factories or even the process guys and ladies that were working in there gave you an innate understanding of some of the problems that come up with this sort of technology.
The main one was obviously the control of grain growth and types of grains within superalloys. Obviously the actual physical furnaces, the controlled atmospheres of the furnaces, including just making the alloy itself. It wasn't just burned in a great big pot, as I remember some of the copper being. The other was the way robots are used, the way environments that are harmful to human beings can be completely devoid of those human beings, so the health and safety issues are completely eliminated by the fact you've got robots. Those are the two areas I would say.
During my visits to these companies, a lot of them were quite happy to demonstrate some of their systems and get me to talk to some of their employees as well. So I spoke to quite a wide range of people to ask them, well, why are you doing that in that particular manner? So that helped with the tacit knowledge.
I shadowed a member of the maintenance team. There's a lead senior engineer. He's electrical, but it didn't really matter because they're multi-skilled. And I was able to go throughout the whole plant, from the foundry through to the specialist furnaces, the ones that do the special grain structures, cleaning, maintenance, all sorts of things. They have EDM, they have computerized cells, they have computerized dipping for the moulds, covering the moulds with ceramics and all that sort of thing. So I was able to go throughout the factory because I was shadowing him.
How did you turn it into explicit knowledge for your peers and learners?
Well, instead of this being something that's in the classroom, which was here when I arrived, I might add, I can now actually use it. I can pretend I'm the robot arm, I can show it being dipped into the slurry and put into the sand rain box that rains sand, the alumina. I can then show how the hot metal is poured into it. This is glowing white red. It's incredible to see. It's almost translucent. And how inside the furnace, after it's put in there and it's all closed off and the inert atmosphere is sorted, they then pour the metal and drop it slowly. It can somehow perhaps help the student in the classroom to see what's going on, besides the video that I use, which also shows it, but not quite in the same way, I feel. And they can hold this, feel the weight, and understand what the materials are that we've been using, the special polymer that's called wax, the special ceramics alumina, the special material that's gone in it.
What I then did was create an activity in a workshop where basically students are identifying faults or tracing faults on a car, right? I mean, one might say, well, that's what they do all the time. But then if it's basically incorporated into their teaching and learning, it makes them a bit more motivated and they kind of enjoy their learning as well.
Well, there's probably three fronts there. The first front is it's ongoing still. We're still in this phase of discovering what's out there. And that's been used to purchase or potentially purchase new equipment for our rebuilds, because what you don't know in all this, we're rebuilding our dairy facility now, classrooms and everything. Part of my knowledge has been transferred into that purchase scenario of where we need to make sure that we've got the right automated equipment, but also it's automated enough to be worked independently still, so that a student can learn how to make cheese still rather than pushing a button. The second area was we're developing with a company called Jisc and Bookmark Productions, an online robotics and automation series of web-based learning through the National Skills Academy. And the National Skills Academy, for those people that don't know, is the academy set up for the whole of the food industry with champions inside. We're the dairy champions. We're helping and working with the champion for robotics and automation called Senfra, who wants some online learning. So my knowledge has been used directly now to write those modules. So that's a web-based application. And then the third bit is actually where you've seen today, and then seen me teaching in the classroom, where I've already taught some advances in infrared technology that I've learned in some factories, X-rays and so on.
And in terms of the explicit knowledge, again, through the publications, I was able to stand up at conferences and say this is what's happening and this is why they're doing it and this is what they've learned from this exercise.
It was quite interesting for me to identify the differences between good laboratory practice and good manufacturing practice. So while I was doing my secondment, when I spent the week in the research and development department, for example, they conform to good laboratory practice, but because it's a research setting, they're not manufacturing anything, so the regulation is different. When I then, having done that week, went into the manufacturing side of the organisation and saw good manufacturing practice, it was really interesting the way that the operations are controlled by the paperwork, standard operating procedures that people use, process operating instructions, which are very precise about the exact way that things need to be done. So that's something that, if I can teach those skills in the centre here, and students are then able to put them on their CVs, will be a real draw for industry.